This is wildcard masks in access control lists. Wildcard masks have a simple rule. The first one is show no fear. As soon as you show fear, wildcard mask has control over you. Wildcard masks are simple arguments that basically cause a matching condition with IP addresses. So inside the argument access list here, this is a simple standard access list. Using the permit command, I'm going to match this condition. So when I turn on the zeros, it says this number has to match exactly. Every bit has to match. To work with wildcard masks, the idea is I can simplify access list lines. So if I were to add another access list number, so let's say I want to block 202.10.10.6 in addition, or I should say permit, instead of just permitting .7, I can do this. So I'll write the command again. And this time, I'll use the same wildcard mask. I have 2 line entries. Now the wildcard mask can be adapted to simplify this whole expression. So I have .7 and then .6 in 2 separate lines. It's very simple now to use a wildcard mask to make that happen. So what we're really looking at is the difference between these 2 access list line entries is the simple last number and the last octet. So what we need to do is break that down into its components and take a look at it. So if we look at the bit pattern, so there's the values of the bits as they go across. We're going to see that 7 looks like this in binary, and 6 looks like this in binary. The matching bits, in other words, the bit that are the same in this whole expression, are going to be this first set of numbers. So those 7 bits match. The bits that are different are the 1 bit. So what we're going to do is simply introduce a 1 into the wildcard mask here to exclude both of those conditions. So our wildcard mask now, instead of being all zeros, looks like this. So let me rewrite the line for you up above. So the line now is access list 9, permit 202.10.10. Now in this case I can use either one of these numbers because both numbers will allow the match and the wildcard mask, simply counting that 1 bit. So as long as this number is in this group I want to match, this wildcard mask will exclude the 1 bit, including 6 and 7. Now we can expand this idea farther. Say I want to group the first 8 numbers, starting at 0 and going all the way to 7. As entry lines, that would be 8 entry lines. But using this idea and looking at what bits I want to match, I can simply adjust my wildcard mask to do this. So what you want to do now is stop this video for a second, pause it, and then look at what you can do with a wildcard mask. When you come back, we'll show you what the explanation is. All right. So now what we're going to do is just take a look at what that answer could be. What's going to happen now is because my mask is going to change, what I'm going to see is what's the common for all 8 of those numbers from 000 to 111 of those IP addresses is basically these last 3 numbers don't matter, the previous 5 do. So we're going to leave those as matches. So we'll use 5 zeros and then take the mask to all 1s at the end. Simply all we have to do now to change this is change the wildcard mask from a 1 to a 7, which is the value of those 3 bits, and we've changed the matching sequence. So now every number from 10.0 to 10.7 will match that wildcard statement. Wildcards also have the ability to not be sequential. In other words, in a subnet mask situation, I can put, I'm stuck to that idea of putting ones on the network side and then zeros. In a wildcard mask, I don't necessarily need to do that. So I can literally change this by saying, changing the order of zeros and ones. I'm now looking at a .6, basically meaning that everything will match this condition except for they have to be even. Because my example IP address is even, and I said match this condition, which is a 0. And that's pretty much how wildcard masks work. Okay, my name is Wayne Jarvimaki. I've been a CATC instructor trainer for 10 years now. Well, the three most important points about wildcard masking. The first and most is not to let the student get afraid of what they're doing. Just the logic of it is intimidating, so a lot of students kind of get afraid of dealing with those binaries systems. And I think the most important part that an instructor wants to get through to a student is that it's really a way to filter, a way to get matches. So we're just taking a look at using the number, the IP number, with the wildcard mask to get a match. The last thing is that never expect a student to get this the first time through. No matter how good you are, no matter how hard you prepare yourself, you're never going to be able to get the first time through with every student. They're not going to get it because there's going to be some resistance. I really think that this is one of those difficult questions because there's lots of resources, and I think it's really a matter of getting a chance to work with other instructors. If you kind of lock yourself into this idea that, well, I can build this from all the material, you're going to find yourself getting lost. And one of the nice things to do is to get a chance to work with other instructors, see how they're doing it, because that simple idea of doing it a different way can just improve your instruction incredibly. I would say you're going to have to work your way through it yourself. And it's a matter of asking questions and then taking a look at it after time, after you've learned it. What did you go through to learn it in your own process? What steps did you have to take to understand it? Because you're going to have to recreate that for the student. Because the student, it's going to be a first-time thing. For you, the first time you teach it, you've probably gone through it hundreds of times. So you have to remember where you were when you first started. I don't think there's just one technique. I could think of hundreds of things I wish I knew when I first started. I think the most important thing is to adapt your teaching to your students. Every classroom's different. Every student's different. And you have to be really attentive to their feedback. If you lose connect with the students, you're not going to be able to teach them. And although you can get a majority with a pretty simple, straightforward plan, saying, oh, this is my lesson plan, this is the way I'm going to do it every single time, you can get a majority of the students. But the trick is to try to pick up those students that aren't quite understanding. So constantly using feedback from them, whether it's simple assessment, questions, maybe even just a lab exercise to check their understanding. And that constant check of understanding is really a best practice.